All right, so unit 1 and 2 together, we're going to be solving absolute value equations today. So I first have a couple definitions for you, and then we will go into some example problems. So first definition is for absolute value. Absolute value is the distance a number is from 0. It is always positive. Okay, so there are some steps to solving an absolute value equation. Step 1 is to isolate the absolute value bars. Isolate means you want to get it by itself. Okay, so you want to, if there's anything on the outside of the absolute value, you want to get them to the other side, and you want just the absolute value bars by themselves. Step 2, you are going to write 2 equations and solve. The reason why we write 2 equations is because absolute value always changes your answer to positive. But if the inside is negative, that's the second answer. For example, if I give you the absolute value of positive 3, what's your answer? 3. What about the absolute value of negative 3? What's the answer there? Also 3. So do you guys notice how inside are 2 different things, a positive and a negative, but outside you still get the same answer? That means we have 2 answer possibilities. So when we actually get to an example problem, you'll see what I mean. This is written in algebraic terms. So if my problem is the absolute value of x, any x, equals a number, then when I take the absolute value down, my answer could either be x equals positive a or x equals negative a. When I plug it into the absolute value, it can either be the positive or the negative. Okay? So inside, the absolute value can be negative. It's just the answer that can't be. Okay? When we get to an example, you'll kind of see more what I mean. Step 3, you are going to solve both equations. And here's the all-important, check your answers. And then I just wrote a little reminder down at the bottom. If you get the absolute value equal to a negative, the answer is no solution. You can stop because you cannot have a negative distance. So inside, the absolute value can have subtraction or negatives, but the answer, what it's equal to, has to be positive. Okay? Example 1, I have the absolute value of k plus 6 equals 9. So what I do when I'm looking at these problems is I always go do my steps first. So that's why I have you guys actually write down all the steps, is so that you can go back and basically do any problem. So step 1 said to isolate the absolute value. If you take a look at this, there is nothing on the outside of those absolute value bars. So it's isolated. The absolute value is by itself. So we can move on to step 2. And step 2 says to set it equal to the negative and the positive. Meaning you are going to take what's inside that absolute value and set it equal to positive 9 and negative 9. So we're going to get 2 equations. K plus 6 equals 9. And k plus 6 equals negative 9. Okay, so now we have 2 equations that we're going to solve. So solving these should be pretty easy. You're going to subtract 6 from both sides. And I'm going to get 2 answers. K equals 9 minus 6 gives me 3. And negative 9 minus 6 gives me negative 15. So anytime you have an absolute value, you should get 2 answers, okay? Now, the all-important piece is step 3, which is check your answer. I know that it gets really repetitive after a while, you guys, but we are going to get to problems eventually where if one of our answers might not work and we have to throw one out. So I want you all to get into the habit of checking your answers now. So just really quick, let's do 3. So 3 or the absolute value of 3 plus 6 equals the absolute value of 9, which is 9. So that one works. So then we want to do the next one, the absolute value of negative 15 plus 6, which is the absolute value of negative 9. And the absolute value of negative 9 is what? Positive 9. So both answers check out. Okay, so you just take both of your answers and plug them back into the original equation up there, and check to see if you get the original answer. Okay? All right, example 2. We have negative 2, and since it's right outside the absolute value, that's the same as saying times. So this is going to be negative 2 times the absolute value of x plus 3. I'm going to warn you guys because I know some of you maybe like to get ahead. Your first instinct is probably to distribute the negative 2. Does anybody think that? Don't be shy. It's okay. Don't do it, okay? I'm going to write myself a note, and I say this every single year, and every single year students still do it. Write yourself a note on the side. Do not distribute. Why? Because if you distribute into the absolute value, it changes the value of the problem as a whole. We don't want to do that. Check out what happens. If I'm not going to distribute, but it's being multiplied, what do I need to do to get rid of that negative 2? Divide by negative 2. So divide both sides by negative 2, because our goal here is to get the absolute value part by itself. So we want to divide. Negative 2 divided by negative 2 gives me 1. And I am left with the absolute value of x plus 3 equals what? Negative 3. Now take a look back at your notes a little further up. Is it possible to get a negative answer from an absolute value? No. So you can stop. The answer is no solution. I always abbreviate it. So here's the lesson. If you had distributed the negative 2 into the absolute value, we would have gone through the whole problem and actually gotten 2 answers like we did in example 1. But if you divided before, you would have noticed that it comes out to a negative answer, which means there's no solution here, so you can stop. If you had distributed the negative 2 all the way in, you'd have done all of the work and gotten an answer when there really isn't one. Okay? So you never want to do anything inside the absolute value. You leave the absolute value the way that it is, and everything on the outside gets either added, subtracted, or divided out. Okay? So never do anything to the inside of the absolute value. Got it? Okay. Let's look at the next example. So example 3 wants me to solve 3 times the absolute value of 2x minus 1 equals 45. This one is similar to the previous problem. So you're not going to distribute the 3. What are you going to do? Divide. Good. So everybody divide both sides by 3. Those 3's reduce. And you get the absolute value of 2x minus 1 equals 15. Okay, so we're working on isolating the absolute value. If you guys take a look up here, I now have the absolute value by itself. There's nothing on the outside, right? So it's isolated. So we can take those bars down, and we set the inside, 2x minus 1, equal to positive 15, and 2x minus 1 equal to negative 15. I'm going to give you 2 minutes. Finish those for me. So you should get 2 answers. So to solve these, you are going to first add 1 to both sides. Yes? Okay. This is all algebra 1, so you guys should be good here. When I add 1 to both sides, that's going to give me, 2x equals 16, and 2x equals negative 14. Thumbs up if you've got this so far. Excellent. I'm running out of room, so let me clear some space here. So then what would I do to solve for x? Good, divide by 2. So you're going to divide both sides by 2 on both equations. And you should get two answers. X equals 8 and x equals negative 7. Is it okay to have a negative on the inside of the absolute value? Yes, it's totally okay. So a lot of times I have students that freak out when they get a negative answer. Don't freak out. It's okay because that x is going inside the absolute value. So it's okay to have a negative as your answer to the absolute value equation. Okay? You just can't have a negative on the right-hand side of the equal sign. Okay? So that is example 3. Okay, example 4. We have 7 minus 3 times 3x minus 6, or absolute value of 3x minus 6 equals 14. One common mistake that I usually see here, so I just want to point it out so you guys don't do it, is students want to do this 7 minus 3 part right here. This negative 3 is attached by multiplication, so we cannot subtract it from the 7. So we have to get rid of them individually. So to get rid of that 7 first, I'm going to subtract 7 from both sides. And remember, it's same rules as in algebra when you were solving. If you're solving, you get rid of addition and subtraction first, then you can multiply and divide. Okay? So you always subtract or add first when you're solving, and then you do your multiplication division last. So this is going to give me negative 3 times the absolute value of 3x minus 6 equals 7. And do I distribute the negative 3? No. What do I do? Divide. So divide both sides by negative 3. I love it when this happens. Take a look, guys. We get the absolute value of 3x minus 6 equals negative 7 over 3. Is this allowed? No. So you can stop. So the answer here is no solution. The symbol for no solution is an O with a slash through it. You can write it out like I did in the previous one, or you can give me the symbol. It doesn't matter. Okay? Okay, last one. I have 2/3 equals the absolute value of 2x minus 1. Now, if you take a look at this, it's kind of flip-flop, but that's okay. But notice that my absolute value, there's nothing on the outside being added, subtracted, multiplied, or divided. So it is isolated. So we can go straight into setting it equal to the positive and the negative. So you're going to get 2x minus 1 equals 2/3. And 2x minus 1 equals negative 2/3. Now we are going to have to do some scratch work because these are fractions, but it's okay. You can still do the work even with the fractions. Okay, so don't panic. How would I solve these right now? What would you do? Good, you would add 1. So I want you to add 1 to both sides on both equations. But now we're adding a fraction and a whole number. So I'm going to do a little bit of scratch work off to the side right here. I need to get these to have common denominators. 1 is the same as what over 3? 3 over 3. Right? 3 over 3 reduces to 1. So 2/3 plus 3 over 3 gives me 5 over 3. So this is going to be 2x equals 5 over 3. And then you're going to do the same thing with the other one, except this is negative 2/3 plus 3 over 3. So that gives me 1 over 3. Good. So this is 2x equals 1 over 3. So far, so good? Okay. Last thing is you're going to want to divide both sides by 2. Now, dividing by 2 is the same as multiplying by what? 1/2. So it's the same as multiplying both sides by 1/2. which means my two answers are going to be 5 over 6 and 1 over 6. And that's it.